Welcome. This presentation is for INDE6332, Engineering Project Management. For Assignment 6, I am the Project Manager, Angel Rivas. The team members are Taylor Shaban Kare, Sean Vasishko, and Hard Patel. A summary for this assignment. Our objective is to develop a simplified network based off our WBS and Gantt chart we previously developed. Our methodology is to simplify the WBS into a list of activities, applying predecessors to those activities, then applying early start, earliest finish, latest start, and latest finish, and then portraying that network as an activity on node. Our key results is to determine earliest start, earliest finish, latest start, latest finish, and our critical path. Our activities will consist of construct hull and cabin, propulsion system, electrical system, freshwater system, raw water system, sanitation system, navigation system, anchoring system, research system, hull inspection, hull launch, engine check, sea trial, boat safety inspection, and preparing documents. Here is our table of our simplification for the WBS, where we added a label A through S for each activity. And we also stated the predecessors for each of those activities, which the predecessors are just activities that need to be done before said activity can begin. Here is our activity durations, where each label has an optimistic A, most likely M, and pessimistic B, where the optimistic is the fastest we can think it will be done, pessimistic being the slowest we would think it would be done, and most likely being the ideally when it will be done. Our expected time was determined using the equation on the right, where TE is equal to A plus 4M plus B divided by 6. And our variance is square stress equal to B minus A over 6 squared. Here is our network, where we have the expected time and variance for each node. Each box contains a node, which is also an activity, and under the label there is the expected time on the left and the variance on the right. Forward and backward pass. To determine the earliest possible schedule, we perform a forward pass, and performing a forward pass will give us our earliest start and our earliest finish. Our earliest start will begin with our first activity, which is 0, and the earliest finish that activity will have will be the duration that activity will take to complete, and the following activities will have the earliest start of the previous earliest finish. Next, we will perform a backward pass to calculate the latest possible scheduling without delaying the project. A backward pass will give us our latest finish and our latest start. Our latest finish would be determined using our earliest finish by then subtracting the duration of our activity that takes the most time, and subtracting that to the time will give us our latest start. Here we have a table showing all the activities and their earliest start, earliest finish, latest start, and latest finish, as well as the slack. The slack being the subtraction from earliest start from latest start, with the most slack we have being activities G, H, and I, with a slack of 7 weeks. Here is the earliest start, earliest finish, and latest finish for each node, where we concluded the earliest start and latest start to be 0 weeks, and the earliest finish and latest finish 22 weeks. Here is our critical path, which is the longest we determined our project to last, which again is 22 weeks, and that critical path consists of A, B, C, D, M, N, O, P, Q, and S. Our results, as previously mentioned, is our critical path A, B, C, D, M, N, O, P, Q, S, and our earliest start being week 0, our earliest finish being week 22, our latest start being week 0, and our latest finish also being week 22. Thank you for watching.